Welcome to this tutorial on NumPy logical operations. Today we're exploring the logical XOR function, spelled XOR, which stands for exclusive OR. This powerful function allows us to perform element-wise exclusive OR operations on boolean arrays in NumPy. Before diving into the NumPy function, let's understand what XOR means. XOR, or exclusive OR, is a logical operation that returns true only when the two inputs are different from each other. Looking at the truth table, when both inputs are false, the result is false. When the first is false and second is true, we get true. When the first is true and second is false, we again get true. But when both inputs are true, the result is false. The key point is that XOR returns true only when exactly one input is true, not both. The syntax for NumPy's logical XOR function is straightforward. You call np.logical_XOR, passing two parameters, x1 and x2. These are your input arrays, which can be Boolean arrays or any arrays that can be converted to Boolean values. The function returns a new Boolean array containing the XOR results for each corresponding pair of elements. Let's see a practical example. We create two Boolean arrays, A and B. Array A contains true, false, true, false. Array B contains true, true, false, false. When we apply np.logical_XOR to these arrays, we get false, true, true, false. Notice how the result is true only where the inputs differ. Position 0, both true, so false. Position 1, false and true differ, so true. Position 2, true and false differ, so true. Position 3, both false, so false. An important feature of logical XOR is that it works with numeric arrays too. When you pass numeric arrays, NumPy automatically converts them to Boolean values. Any non-zero value is treated as true, and 0 is treated as false. In this example, x contains 0, 1, 2, 0, and y contains 0, 0, 3, 4. After conversion, x becomes false, true, true, false, and y becomes false, false, true, true. The XOR operation then gives us false, true, true, true. NumPy's logical XOR fully supports broadcasting, which means you can perform XOR operations between arrays and scalars, or between arrays of different shapes. In the first example, we XOR a one-dimensional array with a scalar value true. The scalar is broadcast across all elements. In the second example, we apply XOR to a two-dimensional array with the scalar true, and broadcasting automatically handles the operation for every element in the array. Logical XOR has several practical applications in data analysis and programming. First, it's excellent for detecting changes between two Boolean arrays, helping you identify where values differ. Second, it's useful in validation logic when you need to ensure exactly one condition is met, but not both. Third, you can use it for toggle operations to flip Boolean states conditionally. Finally, it's perfect for data comparison tasks, where you need to identify mismatches between datasets. Let's recap the key points about np.logical_XOR first. It returns true only when the two input values differ from each other. Second, it works element-wise on arrays of any shape, processing corresponding elements pair by pair. Third, it supports NumPy's broadcasting rules, allowing operations between scalars and arrays. Fourth, it automatically converts numeric values to Boolean, treating 0 as false and non-zero as true. Finally, it's the perfect tool for detecting differences and changes in your data. With these concepts mastered, you're ready to use logical XOR effectively in your NumPy workflows.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.